Yeah, welcome back to the second class of your chemistry. In the first class, we discussed about your valency table, your language of chemistry of class 9, as well as also I gave you a very brief description about the periodic table. The previous periodic table that you have learned in class 9, all the older periodic table, as well as also I have discussed with you the modern periodic table. Now, just to start with, now we'll restrict ourselves onto what is there in your syllabus. Your syllabus has the study, the variation in the properties, different properties across the group and the period. But before I start, I want you all to see the modern periodic table again. Even though in the previous video I had given you the periodic table, the flashing of the periodic table, the full periodic table, as well as also the periodic table which is there in your syllabus. Only first 3 periods of the periodic table. Now, what we will discuss here is a very brief description about different groups and periods, and after that we are going to start with the character property variation in groups and periods. Alright, now here we go. We had altogether 18 vertical lines, and 18 vertical lines are what we call as groups. According to the new IUPAC system, all of these vertical lines are recognized as group 1, group 2, group 3, group 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, according to the modern system. In the older systems, these groups were recognized as 1A, Roman 1A, like this, 1A, 1B, 2A, 2B, 3A, 3B, 4A, 4B, 5A, 5B, 6A, 6B, 7A, 7B, then altogether 8. There were 3 vertical lines for 8, 3 of them, and then you have 0 group. So altogether making it 18 vertical lines. But according to the new IUPAC system, we'll go by the new IUPAC system where we have to say group 1, 2, 3, 4, like this till 18. Now each of these vertical line has a name. Now what these names are, let's see. The first vertical line is more commonly called alkali metal group. Yeah, because this group contains all the metals which are alkali metal. It can form alkali very easily. Alkali metal, except for hydrogen, which is not a metal, but it behaves like a metal, alkali metal, so because of that only hydrogen is placed here. This second one, group 2, is called alkaline earth metal. Alkaline earth. Then from 3 to 12, from group 3 till 12, all of them together, 3 to 12, they are called transition metals. These are all a transition element we call, because there are some non-metals, metalloids are also present in that. So we call them as transition elements till 12. And from 13 to 16, we recognize by the first element present in that particular group. Group 13 has the first element in the form of boron. So we call this as boron family. The whole group is called boron family. Then group 14 has the first element as carbon. So we call this as carbon family. Then group 15 has the first element as nitrogen. So we call it as nitrogen family. Then the next one is your oxygen family. Oxygen family, which is group 16. Group 16 is oxygen family. Then 17, very important with respect to your syllabus. Group 1 and group 17, very important, because they are saying with special reference to group 1 and group 17. Group 1, as we discussed already, they are called alkali metal group 1, and group 17 they are called halogen group. Halogen, they are very good salt former. In your chapter, which is yet to come, in chapter number 5, we'll discuss about acid, base and salt. There you will see what is the meaning of halogen. Easily they can form salt, that's why they are called halogen. And the last group, now we call it group 18. Previously this group 18 was called zero group, or we call them as inert gas group or noble gas group. But now, according to the modern IUPAC system, that group is what we call as group 18. Now next, let's discuss now about periods. Horizontal lines are called periods, and altogether there are 7 periods. If you count, 7 are there. And the detailed study about this first period, second period, third period, which is also in your syllabus, detailed study of this 3 periods, we have already discussed in the previous class. And I have also taught you how to write all the elements. There are 18 elements in period 1, period 2 and period 3. 2 elements in period 1, 8 elements in period 2 and 8 elements in period 3, total 18. And we have already learned in the previous class. Alright, now let's see. These periods are also known by a name. First period has only 2 elements. One is hydrogen, the other one is helium. That is why the first period, since it contains the lowest number of elements, we call period number 1 as shortest period because it contains only 2 elements. Going on to period 2. Period 2 has, and period 3 by the way, both period 2 and period 3 have in them 8 elements. And as 8 elements are present, so because of that, they are called short periods. Similarly, 4 and 5 have in them 18, all of them are filled up, 18 elements. That's why they are called, this both 4 and 5 periods are called long periods. Then going on to 6, in addition to this 18, you'll see that in lanthanide, in one of the elements which is lanthanide, there one arrow is there and one row is what is added there. If you count this all 18 and plus this lanthanide series, cannot be accommodated, that is why we have written here separately. This collectively will make up altogether 32 elements. That is why this period 6 is called the longest period, longest. Whereas in group 7 also you have the same 18 elements of their actinide series in just below La. If you see, then actinide, this actinium series which you have here below, again it also has a row. Collectively, if you count, total will come 32. But now let me tell you that this period is something which will not restrict only 32, because all new elements, new discoveries which are coming, they are all coming in this period. That is why this period is known as the same name as the previous one, longest period. But more than the longest period, we know this period as incomplete period, because all new elements are getting added up in this period. So because of that only, we know this as incomplete period. This is what is the description about your groups and periods. Now we'll start. Now, what is periodicity? The property that reappears after regular intervals. Meaning, as you go from left to right, as you go gradually from left to right, or as you move from top to bottom, there are certain properties which will reappear, that is, appearing again and again. That very property is what is called periodicity. Or, in another word, you can also say that the gradual variation. Now, when you say variation, a small increase or a small decrease. That means as you go from here to there, certain properties are there, there will be a gradual increase which will take place, or in other cases, in other properties, there might be a gradual decrease. So, not a sudden, but a gradual increase or decrease in property which is being seen as you go from left to right, or as you move from top to bottom. This very changes that you see, a gradual change, gradual variation is what is called periodicity. So here we are going to discuss now about the different periodicity of different properties. There are altogether 16, 17 different properties that you can learn in the periodic table. But your syllabus mentions only 6. So I'll restrict myself to only these 6 properties. Now what these 6 properties are? Your syllabus mentions. First one is atomic size. Atomic size. How does atomic size of an element change as you go from left to right in a period, or as you move from top to bottom in a group? Increase, decrease, remaining the same. So, or what changes do you see? What variation do you see? That is what we are going to discuss. Number 1, that is atomic size. Second one is metallic character. As you move from left to right or top to bottom, what is happening to the metallic character of element? Is it becoming more metallic, or is it becoming just the opposite, non-metallic? Third property is non-metallic property, metallic and non-metallic now. So altogether 3. So atomic size, metallic property, non-metallic property, 3. Then the other 3 that you have is ionization potential, that is number 4. Electron affinity is number 5, and the last one, electronegativity. So we are going to discuss these 6 property changes or periodicity of these 6 properties as we move from left to right in a period, or from top to bottom in a group. Alright then, let us then first start with atomic size. Now, before I explain to you all this, now since you people know how to write elements till 18, period 1, period 2 and period 3, the trick lies here that you should be able to write even in the exam hall. Now if you are confused, rather than mugging up what is increasing, what is decreasing, now I'll give you a simple trick to remember how or what periodicity change is taking place as you go from left to right. By the way, usually when you say period, this is period, horizontal line, 7 periods. You move from left to right. For example, if I'm talking period 3, left to right, you're going from left to right. So usually for period we say left to right or right to left. And for a group, yeah, vertical line, these are vertical line. You move from top to bottom. As you gradually go from top to bottom, what changes do you see? That only is what we are going to learn. So that means the periodicity of the element as you move from top to bottom in a group. In a group, again I'm repeating, in a group it is top to bottom. So if you are talking about a group, then we say top to bottom. And for a period, as it is horizontal, we move from left to right. So now our study is this one. How in a group, this property, 6 properties are changing as you go from top to bottom in a group, and in a period as you go from left to right, how they are changing. Okay, so before I start now, something which I'm going to do will help you in fact in memorizing this property changes. Okay, since you people know how to write all the elements till 80, okay, here you go. Starting with hydrogen, lithium, sodium. Okay, you can see that lithium, then there helium was there, then that sentence, life be bore if class not offered free needles, that one full if you go there. I don't need that. I don't see. I need only this one, and this I wrote the first line, that is group 1. I wrote only group 1. Then next one, I'm going to write this full period, first period 3, sodium, then it was magnesium, here you are. Now if you want, you can complete the full, but then to understand the periodicity, the change in the variation, whatever variation is taking place, different properties, this is what is going to help me. Now don't forget hydrogen is the first element, so its atomic number is 1. So yes, atomic number is 1, so configuration is also 1, electronic configuration is 1. Lithium, helium is 2, then lithium is 3, so 3 means configuration is 2 and 1. So the first cell is 2, the second cell is 1. So and then again you have 8 here, so if you reach there, then that is what will make it 10 total. So this is 8 plus 2, 10. So this is the 11th one. So sodium is the 11th one. So 11th one means configuration is 2, 8, 1. 2 plus 8 is 10, 10 plus 1 is 11. Then same way for magnesium it is 2, 8, 2, because it's the 12th element. Atomic number is 12. This is 2, 8, 3. This is 2, 8, 4. This is 2, 8, 5. This one is 286, this one is 287, and this is 288. Okay, there, argon total 18. So 8 plus 8, 16, 16 plus 2 is 48. Now, why have I written this configuration of this element? Because this is what is going to give us an idea about how the property changes are taking place. Okay, now, let us then start now with the first property change. I'm going to discuss with you 6 of them. Yeah, starting with the first one, atomic size. Now, as you go from top to bottom in a group, as you go gradually, first one, hydrogen, lithium, sodium, or here magnesium, group all, aluminum, this way. As you go from top to bottom, as you move downwards, in each of the group, if you are moving down, then what happens to the size of an atom? Atomic size means size of an atom. Are the atoms becoming bigger and bigger? Are they becoming smaller and smaller, or are they going to remain the same? Atomic size sometimes is also called atomic radii. Radii means plural form of radius. So it is understood that if this is an atom, you now what is the structure of atom? Size. Bigger this one, the bigger the size is. Or radius. From the center till that point is the radius. So bigger the radius, bigger the size. So sometimes in the exam you may be asked atomic radii. Don't forget radii means the same thing as atomic size. Or in other times you may be asked atomic size, atomic radii, both of which are the same. Now, what is this atomic size or atomic radii? Now, the tendency for an atom to lose or to gain, I repeat again, to lose or to gain electrons. Now again in your lower class, you have learned about that elements can lose electrons or can gain electrons. For example, if I am talking about one element X, this X may lose 1 electron, sometimes 2 electrons, sometimes 3 electrons, and then when it loses, it becomes X plus. Don't forget now it had equal number of electron and proton. But now it has lost one electron, means now it has one proton more. Proton is positive charge, that's why now this X is getting one positive charge. Same way, if it had lost 2 electrons, then this becomes X plus 2. You can see charge X plus 2. Then, same way, element can also gain electrons. So if Y is gaining 1 electron, previously it was neutral, no charge. Electron and proton numbers were same. But now as electron number has increased, so now it becomes Y minus. That's why positively charged particles are called cations. They are called cations, whereas negatively charged particles, they are called anions. So anion is negatively charged, and cations and anions, don't forget, they have the stable configuration. Now when I say stable configuration, they have the configuration of 8 on the outermost shell, or in some cases they will have duplex configuration of 2. That is what is said to be the most stable. And cations and anions, they are stable. And if cations and anions are stable, then we say that that stability is attained by either loss of electrons or by. Now again, coming back to atomic size or atomic radii, the size of an atom, bigger or smaller, depends on 2 factors. So the factors on which it depends. The first factor on which atomic size depends is the number of shells. Yeah, now don't forget, what do we mean by number of shells? Yeah, if this one is a nucleus which contains protons and neutrons, here electrons are housed in a cell. First cell, second cell, third cell. So here you can see in the diagram there are 3 cells. So some may have more than 3, some may have only 1, some may not have any. So that's why this line, the orbit on which the electrons actually revolve, that is what we call as cell. How does it depend? Obvious, if only one cell, size is smaller, and if more cells, size will be bigger. So that's why here, as a science student, you people know now what is the meaning of directly proportional and inversely proportional. So in physics you have learned what is directly and inversely. Now let me say it again. When one increases, the other one also increases. That is, the second property also increases. When this decreases, this also decreases. Such kind of increase and decrease, such kind of variation which is taking place is what is directly proportional. Like for example, you have learned in chemistry in class 9, gas law, about Charles law, temperature, absolute temperature and volume, directly proportional. Whereas in Boyle's law, you saw that when one increases, the other one decreases. That is, when pressure is increased, volume decreases. When this is decreased, this increases. Such relation is what is called inversely proportional. So I will be using the word here, directly proportional and inversely proportional. Now, here is very easy. Now, number of cells increases means the size of the atom becomes bigger and bigger. That's why the relation is cell is increasing, number of cells becomes bigger and more. If the number of cells increases, size also increases. That's why if I write, if the number of cells is increasing, okay, let me represent it in the form of arrow. You don't write arrow. As a shortcut, I'm using the arrow sign. If number of cells is increasing, then our atomic size also will increase. Whereas here, when I write AS, atomic size is standing for, AS is standing for atomic size. So directly proportional. As you can see, arrow is here also. This is also pointing up. This one is also pointing up. So atomic size and number of cells, they are directly proportional. Now, the second factor on which it depends is called nuclear charge. Okay, first let's discuss what is this nuclear charge. You have not heard about this word before, nuclear charge. Nuclear charge means the number of protons present in the nucleus. How many protons are present? But number of proton actually is called atomic number.